Hello, my name is Bartek McCormick, and this is the date of birth project for the PLTW-DE class. My partners in this project were Nick Karski, Anishvar Tamili, and Devlin Moody. In this project, we took one of my partner's dates of birth, which is Nick Karski's, which was December 31st, 1998, or 12/31/98, and through sequential logic, we were able to output his date of birth on a 7-segment display. I'm going to be going over how we did that. So we started by making a truth table. We used binary inputs, 3-digit binary inputs, which essentially give us 8 different outputs. This would range from 000 to 111, and each of these values would give us the appropriate number or character, and then when they would be activated in sequence, so going down this table, they would make his date of birth. So for each individual output, so for example 1, if you go across the truth table, you see all of the segments, which are represented by A, B, C, D, E, F, G, which need to be high or low to get that output. So for example, for 1, A would have to be low, B would have to be high, C would be high, D would be low, E would be low, F would be low, and G would be low. This is the same for the rest of these outputs. And then if you go down a column, so for example, again for A, you see all the individual times where that segment as a whole is high or low. So for example, when X is low, Y is low, and Z is high, A is high, and that holds true for the rest of the table as well. Next step was to take what I just described, the columns for each individual segment, and find simplified logic expressions for each of those individual segments. So for example, after K-map simplification, A would be X naught and Z, or X and Y, and that's every single time segment A will be on. And so we just did the same thing for every single segment, and here are all the simplified logic expressions that we needed. The next step was to make a circuit in multisim. So we were able to figure out what gates we needed to use and to test the circuit to see if it would work prior to assembling it. So we used AOI implementation, and we used here we used NOR, and here we used NAND gates for 2 of the segments. And here you can see the simplified logic expressions for each individual line. Okay, the next step was building the circuit, and here's a quick video of us demonstrating how it works. So that's the circuit as a whole, and my partner's just going to go through the switches to make the date of birth appear on the 7-segment display. And that's about it. Thank you for watching.